Okay, good morning, everybody. Thanks for the introduction. It's correct, we are working a little bit on nanotechnology or nanomaterials, so we switched to that topic. And if you look at nanomaterials in the food sector and the aims, so there are no other aims in food processing introducing nanotechnology. So it's improved production processing techniques, improved food contact materials, modification of taste, texture, and sensation, monitoring food quality and freshness, reduced fat and salt content, enhanced nutrition absorption, and improved traceability and security of food. So that's some aims introducing nanotechnologies or nanomaterials. If you look at the creation of nanomaterials, we only have two processes. That's top-down, starting with big materials using mechanical thermal energy. That's what we are using in my lab for plant materials and minerals. We need a huge amount of energy to reduce size to the nanoscale, so it's surely not economic to do that. It's more proof of concept. Or bottom-up, so creation of nanoparticles from single molecules by chemical reactions. So we use enzymatic cross-linking or molecule self-association or aggregation. That's the easiest things to do. It's by itself, so you do not need to do a lot. And that's, you see, I'm also working for the German government, so also for regulatory purposes. The problem we have is we always talk about nanotechnology, but what we want to regulate are the nanomaterials. So especially if you look at food processing, if you apply the toolbox of nanotechnology, you might end up with nanoparticles, but sometimes, or very often, you do not. You create much bigger structures, even if you use nanotechnology. And the other way around, most people think nanoparticles derive only from nanotechnology, so the application of nanotechnology, surely not. So even using our traditional food processing technology might end up with nanoparticles. And that might be a problem. So if you look at food processing, you start with raw materials. You do the processing, you end up with a huge variety of food products. And you need to look at naturally occurring nanostructures in the food. And if you process your raw materials, proteins, starches, and fats undergo structural changes at the nanometer or micrometer scale. So in the final food products, you might have the natural occurring nanostructures and the nanostructures introduced through processing. I always say nanostructures, it's not necessarily a nanoparticle. And if you look at these naturally occurring nanostructures, proteins, so a protein, I would say it's a real nanoparticle, between 1 and 10 nanometers size. Myofibrils in meat is a nanostructure, the same as polysaccharides and lipids, linear polymers, so one-dimensional nanostructures. The planar assembly of cellulose fibrils in plant cell walls, a two-dimensional nanostructure naturally occurring. And if you look at food processing operations like coagulation, emulsifying, homogenization, in milk, you reduce the size of the fat globules to stabilize the milk. So you reduce the size to about 100 nanometer. So you produce a nanoparticle, even if it's a soft nanoparticle. Foams, so if you drink a glass of beer, if you have ice cream, you create two-dimensional nanostructures. If not, they are not stable. And custard and yogurt involves the creation of three-dimensional networks, again, nanostructures. That's the things we do not want to regulate. So we do not want to start to regulate on the nano area, all these kind of things we had for years. What we want to regulate are the engineered nanostructures or nanoparticles. And if you look at the application of nanomaterials in the food sector, some of the particles you add directly to the food. So that's what we call nano inside. Some other particles or structures you have outside in packaging and surfaces from the equipment you use for food processing. So, for example, novel food structures, nanoemulsions. Then we have food supplements already on the market. For example, minerals, which are nano-sized. We have something completely different, nanofilters. So, surprisingly, in Germany, we have a discussion about nanofilters and the risks on using nanofilters. So it's a nano hole, it's not a nanoparticle. You do not get anything in nano in the final food. For food analysis, nanosensors. Food contact materials, I think that's where we have nanomaterials on the market worldwide, not necessarily in the European Union. And if you focus a little bit more on agriculture, we have nano-encapsulated pesticides or nanopesticides like silver. Food structures, there's a lot of work going on to improve texture or modify texture, consistency, mouthfeel, sensation, energy density. So, for example, companies are working on fat reduction in ice cream to change the structure of the ice cream that you get the same mouthfeel as it used a lot of fat, but it's nanostructured and therefore low in calories. Another example from the Netherlands, alternative protein source. So they use calcium caseinate and fat. The structure, they report it's like chicken meat. So, fortunately, I never tried it. I do not know. Another example from the Netherlands, fat-reduced mayonnaise. So in general, mayonnaise is emulsion, oil and water emulsion, and if you have a water in oil in water emulsion, so the core of the mayonnaise, you substitute the fat for water. That's good for the companies. They sell mainly water, but the mouthfeel is the same as with regular mayonnaise. I need to say, the emulsions, the droplets are bigger than 100 nanometers. So according to our legislation in the European Union, it wouldn't be a nanoparticle. Silicon dioxide, I think that's always in the brass as a nanomaterial. It's a dietary supplement. In general, it's used for their technical properties. It's produced as a nanoscale amorphous silicon dioxide, which agglomerates very easily. So the product on the market is bigger. It's a micrometer scale material, but it contains some nanoparticles. It's an anti-caking agent for powdery ingredients. The addition in the single-digit percentage range. It's widely used since the 60s, and the product which is used today, it's still the same, or almost the same product which is used since the 60s. According to the interpretation of our European regulation by the food industry, it will not be labeled as a nanomaterial. Because they say it's agglomerated, it's not nanoscale, it's bigger than 100 nanometer, therefore no nanomaterial. Titanium dioxide, it's a white pigment used in the food industry. It's the same. It's always in the brass as a nanomaterial, used, for example, in candies, chewing gum, as a food icing material, in dried vegetables. As long as it's a white pigment, it needs to be bigger than 100 nanometer. If it's below 100 nanometer, it's transparent. So from that point of view, again, it will not be labeled according to the interpretation of the food industry so far as a nanomaterial. And that are the major products we have on the European market on the nanoscale. Nanolycopene, produced by BASF. Mean particle diameter, it's 300 nanometers, so slightly bigger than the 100 nanometer threshold. It could be added to beverages, not only to color the beverage, but also to introduce some health purposes. From these food supplements, they are a lot patented, like nanoselenium, nanoplatinum in Japan, nanomagnesium, nanozinc, nanocalcium, nanoiron. Nanoencapsulation is used on one hand to improve bioavailability, especially of fat-soluble vitamins, protection, stabilization for acid-labile compounds to get it through the stomach, masking, for example, omega-3 fatty acid, or to control release. That's very difficult. It works quite well with isolated encapsulation systems in water, in beverages. But if you incorporate this kind of nanocapsule into a food matrix, you get a lot of interactions, and the controlled release you intended might fail. There are some compounds which are encapsulated by different companies. You see it's a huge variety of different compounds. One was on the market in Germany. It was called Beauty Water, terribly expensive. It contained coenzyme Q10. And some of the companies selling these kind of products, Novasol from Aquanova in Germany, Nutralis in Israel, Vesisorb in Switzerland. Again, according to the European legislation, that are soft nanomaterials, and according to the interpretation or the legislation, if you do not have a rigid nanoparticle, it will not be called nano. So all in all, we might have no single nanoparticle or nano food on the market labeled. If you look worldwide, what's on the market? Easy iron, so sun-active iron, which is easily absorbable and does not have the negative effects of iron supplements, so looking at taste or coloring the food. Slim Shake in the US, it's silicon dioxide particles coated with flavor molecules, so you get a more intense flavor feeling on the tongue. Or in Israel, active canola, which contains, in addition, encapsulated phytosterols. Nanofiltration, so in the US we have a nanoceramics for deep frying machines, so you can use the oil much longer. And in the food industry, filters with nanopores might be used treatment of effluents from the food industry and, for example, today in water treatment. So there are still nanofilters available and applied. Nanosensors, nanoindicators, we have heard before some methodologies, detection of foodborne pathogens, detection of toxins and allergens, quality control, freshness indicators, traceability, so you can use the sensors directly in food processing or on packaging. If you look at packaging, the major application is antimicrobial coatings. There are several, or there have been several on the market, nicely advertised. They have entirely disappeared. Not necessarily the packaging, but the advertisements. So nano-silver, nano-magnesium oxide, nano-zinc, whereby nano-silver is the major compound used in packaging. Then nano-clay, for example, to improve mechanical and technical properties or to improve barrier properties. That's one of the major applications of nano-clay in packaging. It's still quite expensive, and according to the packaging industry, the food industry do not want to have these packaging materials. So they do not focus too much on developing this kind of nanoscale containing packaging materials. But there are some of the market used for bottles, wraps, films, containers, mainly in the US and in Asia. And they really could reduce entrance of oxygen by about 80%. They minimize the loss of carbon dioxide. They are lighter, they are stronger. So you might use them for plastic beer bottles, for example. You could use them also for biodegradable packaging material. So you get your clay material back. UV protection, nanotitanium dioxide is used, was in development. Non-stick coating, that's always in the press. It's non-existing so far. So we are far away to get that introduced. They are project running on that to develop non-stick coatings, active and intelligent material. Active means actively change the condition of the packed food to extend shelf life. Intelligent, to monitor the conditions of the packed food, to give information to the consumer. And if you look at what's on the market, again, egg is producing one active material. It's polyamide, nanoclay, and oxygen scavenger. So that's a classical material. The only nano which is in that active material is the nanoclay, not the active compound, the scavenger, and that's true for all active compounds or active packaging materials so far. They all contain nanoclay and the molecular scavenger as with the classical materials. Intelligent food packaging, here, for example, from Finland, a hydrogen sulfide indicator. So that changes colors if you have spoilage microbes in your packaging. That's a nano-sized, from the thickness of nano-sized platelet. So we can surely discuss if that's nanotechnology or nanomaterial. So even if you use probes, DNA probes, oligo probes, to scavenge DNA from a spoilage microbe, it's called nano today. It's in, you can get research money for that. If you want to apply and sell these kind of materials, the term nano disappears. And nanoparticles-based intelligent inks, yeah, you can even use a barcode based on nanoparticles today. Surfaces antimicrobial properties, again, nanosilver. It was used in washing machines, in refrigerators. Again, it disappeared today. Improved mechanical properties and water and dirt repellent surfaces to avoid biofilm formation in the food processing industry. A lot of work is going on in that area. Market situation, if you look at application of nanotechnology, I would be more precise with nanomaterial in the food area. Food packaging is currently outside the European Union. So we do not have a lot of products on the market here, mainly in the US, Australia, New Zealand, South Korea, Taiwan, and China and Israel. Reservation here on the EU market, and I think the food industry still fears consumer backlash, and therefore they won't introduce a lot of nanomaterials onto the market. The problem we have, the market situation for us as regulators is unclear. We do not have a register in France. We have one from 2013 on for all nanomaterials. So there's no specific indication that it's used for the food industry. In Belgium, it started in 2014. Labeling requirements. We have a legislation within the European Union since December last year. I haven't seen any product so far which was labeled as nano. As I said before, silicon dioxide and titanium dioxide, the major products on the market, are, according to the interpretation, no, not to be labeled as nano. They are no nanomaterials. The same for soft nanomaterials, organic nanomaterials. So all the encapsulation systems will not be labeled. The other problem we have is detection methods. So we do not have a validated detection method or detection methodologies available so far to check the presence of nanoparticles or nanomaterials in the food area. The same is mainly true for cosmetics. It's very expensive, not a single validated method available. And a point I didn't raise here, we still discuss about a proper definition of nanomaterials within the European Union. So without a proper definition, it's very difficult to say that a food product contains nanomaterial or not. So thanks very much for your attention.